Hey everybody, like I promised in the previous video, we will use Microsoft Excel to pretty much do the same calculation, solving this system of equation which we actually solved in the previous video in two different ways. One in using some manual substitution techniques, and secondly using the matrix notation. Let me remind you of the matrix notation. So the left hand side of this equation has all variables and coefficients, and on the right hand side we have the constants. So once you have the equations in this format, so what you do is that the coefficients, you put them into the same matrix and you multiply it with the variables. In this case we have x and y. The right hand side is just 29 and 2. So next is, it turns out xy, if you want to isolate that x and y on the left hand side of this matrix multiplication operation, all we need is to multiply both sides of this equation by the inverse of this 2, 3, 1 minus 1, and that's exact. And once you do that, the left hand side, that term vanishes. On the right hand side, because you multiplied both sides of the equation by the inverse of 2, 3, 1 minus 1, you also have to multiply it on the right hand side as well. Make sure it's a left multiplication. Do you guys agree? All right. And that's it. So once you multiply, hopefully you get the desired result. So in a sense, what we need is two steps. In two steps, we can solve this problem using Excel. Step one, all right, so let me show you what I mean by the two steps. In the first step, because the answer is just this expression, all we need is to find the inverse. Find inverse. Well, find inverse of, we would like to, let me just go ahead and use a, oops. All right, so maybe like this. Well, yeah, it doesn't show up, so I'll just go ahead and unwrap it. So find the inverse of the following matrix: 2, 3, 1 minus 1. Well, that's very easy using Excel. So because that 2 by 2 matrix, its inverse is also 2 by 2. So what I will do is I'm going to just go ahead and select a 2 by 2 area. And there's really two ways to finish the problem. Either you can directly write the formula, but pretend for a minute you don't remember the formula. So you go back to the formulas area and math and trigonometry. So we go here, and from this drop-down menu, we need to find the inverse. So that's it. So matrix inverse. So what is the matrix that I'm trying to calculate the inverse? It's this matrix over here, and that's it. So the end result will show up here, and actually it's already giving you a snapshot of what the end result will look like. So you press OK, and that's it. So 0.2, 0.6, 0.2, and minus 0.4. If you remember from our solution, we found them as 1 over 5, 3/5, 1 over 5, and 2/5 again. So that looks a correct answer. So inverse is given by, perfect. So we found the inverse of this matrix. Let me just go ahead and highlight it. So this is the matrix of coefficients, and the inverse came out this way basically. Let me make it orange color. Awesome. Now step two, finally, step two, what we need is to multiply matrices. Multiply matrices. And it turns out this is also easy. So what are the two matrices that I'm trying to multiply? On the one hand, the inverse matrix that we just derived, right? So you can either select the whole thing, or let me do it in two steps. So all you do is Control C. Let's just paste it here. Well, it didn't work because it has a formula. When I paste it, I need to make sure I'm just pasting the values. There you go. And we want to multiply this with, let me put a multiplication sign between them. Let's first merge these two cells. There you go. And there you go, and let me put a hypothetical multiplication sign. So we're trying to multiply that matrix with 29, 2. You guys see that? So we know that the answer, because this is a 2 by 2 matrix multiplied by a 2 by 1, the result should be a 2 by 1. So I know the result will be just something like this. So let me just go ahead and highlight the result, let's say here, and that will give me the desired answer of 7.5, right? So if things go with the plan. So what I do here is yet another formula, and it's a mathematical formula. Again, I need to go all the way to the letter m. This time, instead of m inverse, we are going to use m multiple. So this is multiplication. Later on, we will also learn about the determinant. There's a second method to find the solutions, but okay, for this purposes of this one, we're just going to use this one. So what are the two matrices we are trying to multiply? Namely this one multiplied with this one. Order turns out to matter because matrix multiplication is not a commutative operation. All right, not commutative means when you change the order of the two terms that you're trying to multiply, the matrix you are multiplying, the end result will be different. This is unlike, let's say, the set of integers, right? Integer multiplication defined on integers is commutative. So 3 times 5 is equal to 5 times 3. Two distinct matrices, when you multiply them, a matrix A times matrix B is not necessarily equal to matrix B times matrix A. If those two products were to be equal, then we would say then it would have to be a special property. Okay, so but that's something that we will learn later on. And I just press OK, and boom, we get the same answer. So it is really cool. So, and I can write next to it the answer x equals, and this one is y equals. So really good. Let me just also, there you go, align it like this, and I can make them left indented. Okay, there you go. All right, so x turned out to be 7 and y turned out to be 5 as we predicted. So in the next video, what I will do is I will do the same thing for a system of 3 equations and 3 unknowns. And this time I won't even bother trying to use manually solving it. We will directly solve it on Excel again. This time a 3 by 3 system of equations, linear equations, which we will solve using Excel. So see you guys in the next video.